Hi, welcome back to Solve for X. So today we are doing trigonometry. So we're probably gonna cover the introduction and the reduction formula, special angles, and trigonometric identities. So we are planning on covering as much as possible that we can do. All right. Okay. So we are going to start with a Cartesian plane. So you have something like this. No. So where you're having x and y. So this is an idea of dividing a circle into 4 equal parts. So if you divide a circle into 4 equal parts, you're gonna have the first quarter, second quarter, third, and fourth. So now we know that any line drawn from the center of a circle to the circumference of a circle, that line is called a radius, right? So assuming that this point will be the point at the circumference of a circle, so let's say that point is point P. So then that means it's given by y and x. Then leaving this here being 90 degrees as it is 90 degrees from there. Okay. So now you have x, y, and r. And if we have an angle here, namely theta, then this angle becomes our reference angle. Then that leads us to having what we call trigonometric ratios. Okay, so trigonometric ratios, we know them. Normally we are all used to SOHCAHTOA, right? Meaning that sine will be, the sine of theta will be opposite over hypotenuse, cos of theta being adjacent over hypotenuse, and then the tangent of theta being opposite over adjacent. Okay, so now let's define the sides opposite, hypotenuse, and adjacent in terms of x, r, and y. So we say we have an opposite side, which will be side opposite to the reference angle. That will be the side. So in this instance, it's gonna be y. So y is the side which is opposite to our reference angle, being theta. And then we have the adjacent side. Let me just say ADJ for adjacent side, which would be side next to the reference angle. So the side just next to the reference angle will be x, and then we have the hypotenuse side, of which will be the longest side, or define it as, okay, here it's x, so here define it as or you can define it as the side opposite to 90 degrees. Okay, so now going forward, we have then we express sine theta, cos theta, tan theta in terms of x, r, and y. So being opposite over hypotenuse, we said this opposite side, it's what? Side opposite to the reference angle, which is then y. So it's gonna be y over what? hypotenuse as the longest side, y over r, right? The cos of theta, adjacent over hypotenuse, adjacent hypotenuse, x over r. And then we have the tangent of theta, which is opposite over adjacent, opposite over adjacent. So the opposite side is y, the adjacent side is x, so then becomes y over x. Okay, so these are trigonometric ratios. But then we have something else, which is then the theorem of Pythagoras. So we know that the theorem of Pythagoras says that in any right angled triangle, right, the square on the hypotenuse equals to the sum of the squares on the other two sides. Okay, so basically it means that now that you know what's opposite, what's adjacent, and what's hypotenuse, now it means that if we say the square on the hypotenuse equals to the sum of the squares on the other two sides. Okay, so this is then the theorem of Pythagoras, which is then used here when you're looking for either r, y, or x. Okay, so now let us move or jump to the trigonometric identities. Trigonometric identities. So trigonometric identities, identity number one, we know it as sine squared theta plus cos squared theta equals 1. Okay, and we know that tan theta equals sine theta over cos theta. Now let's prove these identities, right? Prove that sine squared theta plus cos squared theta equals to 1. So when you are proving, you would normally, proving is an idea of showing that this side, of which maybe it's the left hand side, equals to the right hand side by expressing it in that way. So it would normally be you simplifying it to make it the same as the other side. So in this instance, we are going to take your side, this side, because that side we have 1, so there's nothing pretty much we can do that side, but we can work with this one. So this side is our left hand side, equals to sine squared theta plus cos squared theta, right? This is our left hand side. But sine theta, if you draw your diagram here, x, y, r, you put your theta there. So you would say x, y, and r, you know that this is adjacent, opposite, and hypotenuse. Adjacent, opposite, hypotenuse. So sine of theta, also remember your toa. Okay, sine opposite over hypotenuse. So if it's opposite over hypotenuse, this is opposite and that is hypotenuse. So it's going to be y over hypotenuse r squared plus cos squared theta. Cos is adjacent over hypotenuse. That is adjacent and that's hypotenuse. So it's going to be x over r, right? All squared. Okay, so then you know the rule in mathematics which says that a over m all over n could be written as a exponent n over m exponent n. So you apply it here. Y over r all squared could be written as y squared over r squared plus x squared over r squared. So notice this, r squared is a common denominator. So then write it here, say r squared as a common denominator, bring this as it is. Okay, so but you have what? The theorem of Pythagoras says that r squared equals to y squared plus x squared. The square and the hypotenuse equals to the sum of the squares on the other two sides. So that means now you can substitute your y squared plus x squared as r squared. Then you say, therefore, r squared over r squared. Therefore, left-hand side equals to 1, leaving you to having left-hand side being equals to right-hand side. Okay, right, this is it. You can pause, rewind the video, make it go faster or slower. Right, now let's take this one now. So you have tan theta equals to sine theta over cos theta, right? So then when you're having this, you are also trying to prove that left hand side equals to the right hand side. So let's start with the left hand side. Left hand side equals tan theta, but tan theta, tan is opposite over adjacent, y over x. So you say y over x, it's just y over x, right? That's your left hand side. Now go to your right hand side, equals to sine theta over cos theta. Now sine theta is opposite over hypotenuse, y over, that's y over r, all over cos theta is x over r, adjacent over hypotenuse, x over r. So when given this, you can write it as y over r multiplied by r over x. So r and r reduce to 1, then you have y over x. We're gonna hold our session here and then watch out for part 2.